So I've decided to talk about more generally about what I've put here as the title, Foundations of Explainable AI. So to tell you how we view explainable AI more generally, and ground this in the case of healthcare, but also you can ground it in any other discipline or in the domain of application. So the why first. Why? Why explanations? Usually people concentrate on the first two bullets here, understandability of what the system is doing or trying to tell us, so that we can use it more effectively. But there are two other very important reasons, which you see on the bottom, which is contestability. So systems should be able to be contested. In other words, it could be that the doctor or patient or whoever wants to contest the decision or the decision of a system, and that's where the explanation is needed, because you really can't contest the decision. You can contest the reason for the decision. And there's another more general reason, which is got to do with efficacy. Efficacy is a word that we've coined to mean efficacy in ethical behavior, which is only if you have explanations from systems, you can expect to be able to build those systems to have an ethically aligned behavior. Much in the same way how we have ethical behavior by humans in society. We are accountable, and we are accountable through explanations. And we need to explain to the society why we've taken the decision, so that we can be judged whether that was ethical or not. So for the next part, which is the what. So what is the nature of a good explanation? You can see that it has to be really cognitive, in the sense that it has to match the cognitive understanding of the other agent, whether it's human or not, who is going to receive the explanation. And therefore, it has to be in some sort of symbolic form, either a picture or natural language or concepts, as we had before. But again, it has to be not only relevant in the sense, not only it should explain why the system is proposing a certain suggestion, but why it's not proposing other suggestions. So it has to be contrastive. You need to support in your explanation your position, and you also need to support why not some other position. And then for the third part of how, our answer is argumentation, which is the natural way that humans talk about explanations, use explanations, and generate explanations. In other words, humans, for an explanation, for a human explanation, this is giving arguments for and against. Now, which argument you give for and which argument you give against? The arguments you give for are those that are coming out of your model. Argument against, again, could be part of the model, but it could also be driven by an external entity who's contesting the decision by some counter argument, and then you will need to defend against that argument. So really, because we've been doing this for many, many years, we can have this kind of general foundational understanding of explanations. And the important thing, of course, is that we have we can bring this into practice because of argumentative reasoning, the logic of argumentation, which can be automated. So, for example, we will be able to generate in a medical case an explanation like this. where you see here in green that this is the suggestion. This is on a kind of aneurysm application, that this case of 298 is predicted to unrupture in the future. And these are the reasons. As you can see, the green reasons, the green arrow coming, which is an argument against the other prediction. The rupture, the possibility of rupture is supported by mean curvature very low, but this is weaker than the reason or the arguments that support unruptured. And that's kind of a visual thing, which also comes with a verbal explanation, which you can read. We actually generate kind of controlled natural language explanations in our systems, but then we pass it through one of these large language models and we say kind of rephrase this faithfully in a more kind of natural language thing, and you get something like that. So, but the important thing to use a foundation like we mentioned, for example, in explainable machine learning, when we talk about explainable AI, we have to really change our focus. And what we have to think from the very beginning is that we are not trying to build systems to decide or to predict, but we are trying to build systems to explain. So we are going to generate explanations. Okay, this is very important. So in our kind of approach to machine learning based on argumentation, the output is what you see on the right-hand side. Here is a table that splits the data or the problem into 5 groups, 5 main groups, because there's another small number of groups which only have 4% coverage. And each of these groups is actually defined by the way it provides an explanation to the prediction. So as you can see, the first group is what we call a definite group. It has a definite prediction of yes, and it has some explanation pattern, which like one we've seen on the previous slide. The coverage is 60%, and the accuracy of that is 84%. Whereas if you, in the second group, the accuracy is lower. In the third group, the accuracy is higher, is 92, 90. And then there is a big group of 7% coverage, which is in dilemma, which says that I have equally strong arguments for and against here. And I'm in dilemma, and these are very important because the prediction is that I am in dilemma, but the important thing is that I give you explanations for each of the 2 or the many predictions that are possible. And that's very important because this helps me to identify the difficult cases. These, in some sense, are the difficult cases in my data. And these are the ones I really want to discuss with doctors or with other entities to give me more information to carry on learning better. So to give you an example of a dilemma, in this case 195 is the system is in dilemma. You can see with green the strong arguments on either side, and then you can see that both the predictions have strong arguments that support them, and therefore strong arguments against the other prediction, equally strong, and therefore that's why we're in a dilemma. And then if you have the time, you can read the verbal explanation that tells you really why we have arguments which are equally strong. And therefore you present this to a colleague who has a first idea, a premier avis of what's happening, and then it can give you feedback, perhaps where the system is wrongly judging that one feature is more important than the other. Another kind of completely different application that doesn't have to do with machine learning. This is a gynecology diagnostic system that diagnoses possible, out of the 140 possible diseases, what the disease may be. And as you can see here already, you can see here in the red, there's 5. So this is in kind of in an extended dilemma that from the information that is gathered up to now, which is kind of, you can see something in the left, vaginal discharge, burning, postcoital bleeding. You can see that it's in dilemma, but it's reduced the 140, the space of 140 possible diagnoses to actually 12 and then 5, as you can see there. And the explanation that you get is something like this, which I will not bother reading, but the important thing is that explanation should be informative. They should be, as we said, contrastive. It should say, well, what happens about another possibility and why this possibility may be preferred over another one. So here it says, the following further information strengthens this decision. But it says, if you have a history like this, then this disease may not be possible and should be excluded. So again, going to kind of the philosophy kind of thing, or the foundational level, if you really believe in explainable AI, you really believe that your job is to generate explanations, not to first generate a prediction or a decision and then explain it. Your job is to generate explanations. So that's first-class citizen from the beginning. And therefore, you have to move away from things like being too ambitious, that you're going to have a perfect system that does 99% or never gets it wrong, to a system that kind of is reasonably good. And this will be acceptable and tolerable because it has the explanation. The explanation is the thing that allows you to get away from this fancy thing that I want to have a perfect system, because you are perfect or you're good in the easy or clear cases. The explanation is there, and there's the difficult cases which can appear like dilemmas, and you can be honest and say, these are the reasons why I cannot decide. So you go away from this brittle, we heard about brittle explanations, brittle to flexible explainable models. You don't have rules that always need to be respected, but you have arguments and justification. And more importantly, it tells you building a good explainable AI system is not a one-shot process, but it's a continuous process. You have the explanations. The explanations open a dialogue with other experts. The experts give you feedback, and therefore you can get better and better. So therefore, that's how we're using it in healthcare or in kind of medical AI to make the learning a continuous process. And just to show you, as we mentioned at the very beginning, these foundation that we talked about, argumentation-based foundation or explainable explanations first-class citizens, it's something that you can apply in any decision problem. So for example, here showing you something from another system, you have an investment policy which is given in natural language at the very top, and then you take these different stocks that you might want to invest or not. And as you can see, our system COGNICA gives you an explanation which is in control natural language there. It can be rephrased, as I mentioned, by some large language model. And we've been doing this for some time, and you can see that the ChatGPT 3.5 prediction is different, the explanation is different. And what is important here is not the fact that they are different explanations, but that they're different predictions, but that the explanations are different. So what we're trying to do actually with this research here is to use these symbolic generated explanations by the COGNICA system, which is cognitive argumentation, to generate learning data for the large language model to get it to be more aligned with a kind of more formal explanatory reasoning of argumentation. So that's it. So thank you. I put this thank you with inside this pictures of aneurysm that I mentioned before, just to make sure that this is kind of linked to medical AI.